Here we have an interesting question. We've been given two chambers with gases at pressures and volume and temperature as given P1 V1 T1 P2 V2 T2. Now it is also given that the walls do not allow any exchange of energy. We need to find out the final pressure and temperature of the mixture of gases when the knob is opened. So for this question, the first thing we realize is that walls do not allow exchange of energy. So because of this, work done by the surrounding on the system is 0. The heat exchange is 0. Therefore, change in internal energy of the total inside system is 0. Therefore, initial internal energy of the whole system will be equal to the final internal energy of the whole system. So this can be written as U initial is equal to internal energy of this gas plus internal energy of this gas in the two chambers. This can be written as NCV into T. This is equal to CV into PV upon R. So CV into P1 V1 upon R plus CV into, now CV can be taken to be same for both the gases. Both are of the same type, either monoatomic or diatomic, due to which CV is equal to F by 2R. Let us assume the degrees of freedom is same. It is given rather that the degrees of freedom is same. Therefore, CV into plus CV into P2 V2 upon R is equal to the final internal energy, that will be equal to CV into P final, P dash, let that be P dash, into V1 plus V2 upon R. Now CV upon R can be cancelled to give us P1 V1 plus P2 V2 upon P1 upon V1 plus V2 is the value of P dash. So we directly get the value of pressure of the final system or combination of gases simply by applying internal energy conservation. Now we need to find out the final temperature of the gas. For that, there is another very simple equation that we will use, which people generally forget, and that is conservation of moles. The initial total moles of the system will be equal to the final total number of moles of the gases. Since none of the gases are reacting, the gases are not reacting with each other, therefore the total number of moles will always be the same. Now PV is equal to nRT. Therefore P1 V upon PV upon RT should be constant. Therefore P1 V1 upon RT1 plus P2 V2 upon RT2. This is the total number of moles in the two chambers respectively. This will be equal to the final pressure P dash into volume, that is the total free volume, upon R times T dash. We can cancel R to get P dash upon T dash is equal to P1 V1 upon T1 plus P2 V2 upon T2 upon V1 plus V2. Now we need to find out T dash. It is pretty simple. We will just put in the value of P dash from here to there to get P1 V1 plus P2 V2 upon V1 plus V2 upon T dash, that is equal to T dash into P dash is equal to T dash into P1 V1 upon T1 plus P2 V2 upon T2 upon V1 plus V2, which gets cancelled from the left hand side. This gets cancelled, V1 plus V2 gets cancelled to get, so we get the final value of T dash as T dash is equal to P1 V1 plus P2 V2 upon P1 V1 upon T1 plus P2 V2 upon T2. So final answer for the pressure of the combined system of gases is P1 V1 plus P2 V2 upon P1 plus V2, and for the temperature comes out to be P1 V1 plus P2 V2 upon P1 V1 upon T1 plus P2 V2 upon T2. So what we learned from this question was that you can apply very simple equations of internal energy conservation and conservation of moles of the gases to solve simple questions.